Today we'll be doing the derivative of f of x over g of x. So we're going to show how to prove the quotient rule. And to do that, we can notice that we can write 1 over g of x as g of x to the negative 1 power. So we can implement that here. So the derivative of, so now it's going to be f of x times g inverse of x to the negative 1 power. And now we can use the product rule. So we can label this f and this g. So that's g f prime plus f g prime. So the derivative of f of x times g to the negative 1 power is g, which is g to the negative 1. F prime is the derivative of f of x, and then plus f, which is f of x, times g prime, which is the derivative of g of x to the negative 1 power. So the derivative of f of x times g of x to the negative 1 power is g of x to the negative 1 power times the derivative of f of x, it's just f prime of x, plus f of x times the derivative of this. We could use the power rule, so bring down the negative 1. So negative 1 times g of x to the negative 1 minus 1, and times the derivative of g of x, which is g prime of x. So this is equal to g of x to negative 1 times f prime of x plus f of x times negative 1 g of x to the negative 2 power times g prime of x. And I could distribute the negative here. We have g of x to the negative 1 power times f prime of x, and a minus f of x times g prime of x, and then times g of x to negative 2 power. And now we can rewrite this as f prime of x, and I'm going to bring down the g of x to negative 1 to the denominator, because we can do that, minus f of x times g prime of x, and then the same thing for here. In the denominator, g of x squared, and here we could just get a common denominator, so we can multiply both this one side by g of x to get a common denominator. So you have g of x times f prime of x minus f of x times g prime of x all over g of x squared, and that is equal to the derivative of f of x over g of x. And that is the final result. You usually see this result in like a standard calculus book, but I just showed you how to actually prove it. And yeah, that's basically it. So thank you very much for watching.